right? So many people feels difficulty in identifying the variables or separables. So now actually let us take few examples on this and then actually try to solve it. See this, find the general solution of x plus y into dy by dx. While identifying the solutions of the differential equations, the first and foremost is the variables are separables. So when we wanted to identify the variables to be separable, so first of all actually you have to look at the problem statement and then it will try to analyze the problem statement first, so that whether we were able to identify the variables into a separate groups or not. So for example, if I take one problem, see this, x plus y dy by dx is equal to 0. X plus y dy by dx is equal to 0. Now we wanted to solve this differential equation. Here actually the difficulty in differential equations is, suppose if I give the problem statement, in that problem statement I myself actually will be stating that this is comes under the category of the variables are separables, or actually if it is comes under the category of homogeneous equation, I will be stating that, or if it is coming under the category of reducible to homogeneous format or exact format. So if I say explicitly, then actually you can easily find out the solution, but the difficulty lies in identifying to which category it belongs. So that is the difficulty that is involved. So especially in differential equation, why many people feel difficulty is identification of the category itself is very tough. So here actually by looking at the problem statement x plus y dy by dx, from this we can conclude that this is of the category of variables are separables. So here actually why variables are separables, here it is, suppose if I take this dx and then actually I can convert this into x dx plus y dy whole divided by dx is equal to 0, or this can even be written as x dx plus y dy is equal to 0. Now see this, here actually the function of x multiplied by dx and the function of y multiplied by dy. So here actually I could able to separate x alone and I could able to separate y alone, as I could able to separate into the categories of x and y. Hence actually the variables are separables. Variables are separated now. Now once you identify the separation, then actually it is up to you how do you wanted to do the integration. X dx plus y dy equal to 0. Now I can integrate it separately, as x is coming under the category of dx. So this is x square by 2 plus y square by 2 is equal to some constant, or x square plus y square is equal to the constant a, where a is equal to 2c. So that is up to you how do you want it to treat this arbitrary constant, because here actually c is a constant, a is also a constant, but the relation between c and a is 2c is equal to a. So finally, as this is an arbitrary constant, you can put your own variable. So you can put any name to that one. So you can put c and you can still write 2c, or you can put a and then you can define a is equal to c, or you completely forget about this and then it will still, you can just keep it x square plus y square is equal to a. That itself is correct. Why? Because this is being the arbitrary constant. You have got the flexibility to identify this arbitrary constant value depending upon the initial conditions. So the initial conditions are nothing but actually during the initial state how the system is behaving. So that information we know, because whenever we start the bike, we know that actually we started with 0 velocity, and that is the place actually where we start counting the displacement. That means the displacement is 0, I know, and that is the time 0. That means that is where I started counting the time. So whenever I am starting the bike, so the bike actually we have got 3 informations. I started with 0 velocity, I started with 0 displacement, and I started counting from there. Hence actually the time is 0. So t is 0, x is 0, and v is equal to 0 when we start the bike. This is what we call as the initial conditions. Based on the initial conditions, the differential equation will be solved for the arbitrary constant values. So that's why whenever we solve a differential equation, when there is an arbitrary constant that is coming into picture, you keep that arbitrary constant as it is. So whether it is 2c or log c or any kind of constant, you can still treat as a simple constant a. Got it? So many people will get confused. As it is c, we have to keep it 2c here. May not be. You can still keep it as a single variable called a. So which is a constant here, and this constant is called as the arbitrary constant. This value is calculated based on the initial conditions. Then you will get the appropriate value depending upon the initial scenario. If you treat this as 2c, c will get, suppose actually you still treat this as 2c, and then you got the initial conditions based on that, c value coming out to be 2. Then if you have treated that as a, then you know that a is equal to 2c, then you might have got the based on the initial conditions, if you substitute it, a will come out to be 4. So whether you keep c or whether you keep a, it will not make any difference in our differential equations. Got it? Okay. So this is variables or separables. Note down one more. E power x into dx. dy by dx is equal to e power x plus y. dy by dx is equal to e power x plus y. Now you tell me whether this equation comes under the category of variables or separables or not. Will it come under the variables or separables? Yes, it will come under the variables or separables case. Why? Because e power x plus y can be written as e power x into e power y. Now if I write in this manner, then actually dy by e power y is equal to e power x into dx I can write. So this dx I can bring it to this place, and e power y I can bring it to this place. This equation is e power minus y into dy is equal to e power x into dx. Now you can integrate on either sides. So this is e power minus y, integration is e power minus y minus 1 into is equal to e power x plus some arbitrary constant. Or this is e power x plus e power y is equal to some arbitrary constant a. So this is still valid. So minus e power minus y. So this I am bringing on to this side, so that actually it will be plus e power x plus e power minus y. This c I am bringing on to this side, which is minus c. Minus c I am replacing with a. So this a is the arbitrary constant now. Got it? Note down one more. Solve y square minus x dy by dx. Solve y square minus x dy by dx is equal to a into y plus dy by dx. Is equal to a into y plus dy by dx. Now see this differential equation, by looking at it, actually it is very tough to identify whether the variables are separables or not. But actually if you bring into the form of dy by dx equal to, then actually we can think of whether we can bring into the form of the variables are separables or not. So whenever the differential equation is given in a complex way like this, here one dy by dx is given, here there is one more dy by dx is given. Now club together to a single form, and then actually try to identify whether you can make the variables separables or not. See this, here actually x dy by dx, this I can call this as ay plus a into dy by dx, and this is y square minus x dy by dx. Now this I bring on to the other side, and this I bring on to this side. Y square minus ay is equal to a plus x into dy by dx. See, I have separated now. Now this is simply the function of x, and this is simply the function of y alone. Now this I will keep it on this side, and this a y square minus ay I will bring on to the other side, so that I can make variables or separables. That is dx by a plus x is equal to dy by y square minus ay. Now this is what is the variables. Now it is separated. Once you separate the variables, then actually you can find out the integration value easily. So this integration you can straight away do this. So this is log of a plus x, and this integration here actually this is a little complicated function. So dy divided by y into y minus a. Now here actually you can apply the partial fractions technique so that you can easily separate the fractions and then identify the integral value. See this, here actually y into y minus a. So this is 1 by y into y minus a. This value is a by y plus b by y minus a by y plus b by y minus a. You can identify the values of a and b. That is a into y minus a plus b into y divided by y into y minus a. And this value is 1 by y into y minus a. So these values will cancel out. And then a plus b times y minus a into a. Right? So this is equal to 0 into y plus 1, which essentially means that a plus b is equal to 0. It implies a is equal to minus b and minus a. That value, so here actually minus of small a is equal to 1. Right? So because, sorry, minus a into capital A. So this is equal to 1. Or it implies the capital value is minus 1 by a. So this is the value of the constant. A is equal to minus 1 by a. Now you can replace the values there, and from this actually you can conclude that b value is minus of the a value, which is coming out to be a, 1 by a. Now you can replace it here. A is equal to minus 1 by a and b is equal to plus 1 by a. If you put it in this equation, so 1 by y into y minus a, you can replace as 1 by a you can take out, and then 1 by a if you take out, then that is b value 1 by y minus a minus 1 by y. So this is the value. Now actually you can do the integration of this. Integral 1 by a you can take out, 1 by y minus a minus 1 by y dy. So here actually this is 1 by a log y minus a minus log y plus some arbitrary constant. Now while identifying this arbitrary constant, here actually here logs are involved and here also logs are involved. So I write the arbitrary constant as log c rather than simply c. Why? Because even if you write log c, it will not make any impact on this, because this is still being the arbitrary constant. So here actually 1 by a times of log of y minus a by y, and then so here actually this if you multiply it, so a log of a plus x whole power a plus x, I will keep it as it is, and then actually so this if you further simplify it plus log c, or log of a plus x plus 1 by a log of y minus a by y plus log c. So this a if you take onto the LCM, so this become a log a plus x is equal to log of y minus a by y plus a log c, or this can be a plus x whole power a log of, this is log of y minus a by y times of, here actually as this can be treated as log of c power a, and then you multiply this. So log of c power a, we treat this as log of some constant a. So c power a is equal to a, that is the meaning of it. A being the arbitrary constant. Now here actually this if you multiply it here, this can be treated as log of a into y minus a by y is equal to log of a plus x whole power a. Now this actual log and log, if you eliminate it, a plus x whole power a is equal to a into y minus a by y. So this is the solution where a is the arbitrary constant. So this is the arbitrary constant. So here actually essentially whenever we wanted to find the solution of the differential equation, meaning what we are trying to do is we wanted to identify the relation between x and y by involving some arbitrary constants. When we form the differential equation, if you notice carefully, we have eliminated the arbitrary constants and we brought in the differential coefficients. But here in this case, we are eliminating the differential coefficients. We are establishing a relation between the variables by including the arbitrary constants. That is the meaning of it. So that is, we are finding the reverse procedure. So forming the differential equation brings in the differential coefficients. So solution of the differential equations eliminate the differential coefficients and brings the arbitrary constants and establish a relation between x and y. So finally, actually, we have identified a relation between x and y here. Got it?